When we modify lists in Python, those modifications are not permanent unless we save them to a new variable. This concept is known as in place, and in Python, in place is set to false by default. In NumPy, however, in place is set to true by default, so whatever changes that we make to a slice is going to be permanent and it's going to persist in memory. Let me show you what we mean. Previously we created this array, which we've output down here so that we can see it. What we're saying here is we're going to go to index 5 and change that to 12. Let's do that. And clearly we see that change has been made and it has persisted. There's another concept here in NumPy called broadcasting a change, and what we're saying here is take this slice, inclusive 6 to exclusive 9, and change every element in this request to 123, and then we can output that and see what we get. 0, 1, 2, 3, 4, 5, 6 inclusive, 7, 8, 9 exclusive. Change those three elements to 123, and again this persists. Let's take a slice of our NP array from 5 to 9 and create a new variable out of it. We see we've got 5 through 9 exclusive. And to prove that all of these changes are actually in place, let's make a change to array slice. Let's take the first element, which would be this one, 123, and change it to 1, 2, 3, 4, 5. Then we'll output our original array, and we can see that even though we are abstracted by this intermediary variable, we have still made changes to the original array. There it is. The first element of array slice looks to be the 4, 5, 6th element of the original. So again, in NumPy, in place is set to true by default. One more thing to say about slice modifications is that if we leave this slice definition empty, or what we call a bare slice, and then we assign a value to a bare slice, then look what happens. We've changed all of the elements in this array slice to 55. Up until now, we've been focused mostly on slicing one-dimensional arrays, and things become a bit more complicated, obviously, with higher dimensional arrays, where the slice is not going to be scalar any longer. The slices can become more complex, but we're not unfamiliar with these more complex array searches. Here we have a 3 by 4 multidimensional array, where this is index 0, this is index 1, and this is index 2. Let's print this out so we can see how NumPy stacks these. So if we want to grab this value, index 2 of index 1, this obviously is index 1, and this would be index 2, so this should be a 5. And in NumPy we can simply replace these two brackets with a comma, and we can get the same result. This might explain what we mean when we say that indices in higher dimensional arrays are one-dimensional array. So here is a one-dimensional array of indices into this two-dimensional array. Now we spoke about the conceptualization of array definitions as row and column, and we can see that reflected up here. When we're talking about row 1, see row 1 and column 2, and that is our value 5 in this array.